Now we're going to try to use our skills, all of them, in order to solve a circuit diagram. Now we can use anything here. We can use Ohm's law, that potential difference is equal to current times resistance. We can use our fancy new resistance equations that we learned in series and parallel, and we can also use Kirchhoff's laws in order to do this. Now, I tend to try to do it the easy way, right? I'm going to do anything that's easier first because that just makes sense. And when I first look at this, there's a few things I can do, and I can approach this a lot of different ways. It really depends on what you want to do first. There are a couple things that are super straightforward, though. And for me, one of the first things I see when I see this is I see that I have these two and not the third. And this is going to be really easy. So I can say that V1 is equal to I1 times R1. I can use dear old Ohm's law. This makes it very easy because all I have to do is multiply, right? So my current is 0.1, my resistance is 20 ohms. So when I multiply that, I get my potential difference or my voltage. So I am going to figure that out. Well, that I can do in my head, pretty straightforward. So I know that this is 2 volts. Now, why is this easy? Well, because now I have this resistor is in parallel with this resistor. And what does Kirchhoff's laws tell me? Kirchhoff's laws tell me that any two uh, resistors in parallel are going to have the same voltage or potential difference, which means if that one's 2, this one is also 2. Now I can think about the rest of my potential difference because I know my total is 3.5. If I follow this blue route, I lose 2 there, and I must lose the rest in this one because remember that 3.5 represents the amount of energy per group of electrons. And a group of electrons is only going to follow one of the routes. If it follows the blue route, then it will drop its 2 and the rest, the 1.5 here. Now, I also could have done this using the Ohm's law, V equals IR, and you'll notice 10 times 0.15 is 1.5. So that also helps with my logic. When I go the other way, of course, if I followed the outside route, it would also add up to 3.5. So my logic still holds. Now I'm going to think about current because you'll notice I know my total current, or sorry, I know my total current. Yes, I do, because all of the current has to go through this resistor. No matter which route you take, you go through this resistor, which means my total current up here must be 0.15 amps. And the total current split between these is 1.5 amps. So if 0.1 went that way, the rest, or 0.05, went this way. This now lets me figure out the last couple of things because I can now use my V equals IR here to find out my resistance in the second one. So 2 is 0.05 times R. So 2 divided by 0.05 will give me my answer, in this case 40 ohms. So I know I have a resistance over here of 40 ohms. And I'm just doing my work on the side because then it lets people see what I did. And then finally, I can look up here and do this last one. And this last one, I can also use Ohm's law, V equals IR. And up here, I know that my 3.5 is equal to my 0.15 times my R, which means I just have to divide. And I will find, if I take 3.5 and divide by 0.15, I get 23.3. Now, I often keep a little more accuracy than I probably should when it comes to sig figs on these, and that's because once you start doing a whole bunch of steps, you can lose accuracy really easily. So I'm going to call this 23.3 ohms, which is pretty logical because remember these are 20 and 40, but then we'd have to add the 10. You can double check this whole thing if you want to using the resistance equations 1 over 20 plus 1 over 40, and then find the answer and then add the 10, and you should get 23.3.